Now the next problem is, in the circuit shown below, the key K is closed at t equal to 0. The current through the battery is. Now in all the four options you see that we have to find out the current which is flowing through this battery I at time t equal to 0 and t equal to infinity. Okay, now we know that initially when an inductor is connected across, which is initially having no current, okay, so when it is connected across a battery, then it offers infinite resistance. So initially no current would flow through this, but at time t equal to infinity, that means at infinite time, the stability of the inductor has come and now it will offer no resistance. So this arm will offer only resistance R1. Okay, initially the resistance is infinity and afterwards at t equal to infinity it becomes R1. Okay, so at t equal to 0 the middle arm can be ignored because the resistance it offers is infinite. Okay, now we can find out the current that will flow through this. The current I will be equal to V by R2. Okay, now at t equal to infinity the middle arm has to be considered. Now the effective resistance of this, which is in parallel, will be given by R1 R2 upon R1 plus R2. So the current I that will flow through the battery will be equal to V upon R effective, which is equal to V R1 plus R2 upon R1 R2. Okay, so if you look at the four options, option B is correct. Now let us look at the next problem. The figure shows the position time graph, that is xt graph, of one-dimensional motion of a body of mass 0.4 kg. So mass is given to you and xt graph is given to you. Okay, we have to find out the magnitude of each impulse. Okay, now you can see from the graph that initially it is moving with uniform speed because this angle is constant, it's a straight line. But at this juncture, at t equal to 2, at t equal to 4, at t equal to 6, there is a change in the speed. Okay, now this change in the speed results in the change in the magnitude of momentum, which in turn is responsible for the impulse. We know that impulse I is given by change in momentum p, that is delta p. Now we have to find out impulse at this point, this point, this point. Okay, now for the distance that it travels 0 to 2, the distance traveled is 2 meters and the time that it takes is 1. So the speed is 1 meter per second. So its initial momentum can be written as 0.4 into 1, that is 0.4. Okay, now after the impulse the body is again moving with the same speed. It travels a distance of 2 in time interval of 2, so its speed is 1 meter per second, but you can see that the slope is negative, so that this speed is actually negative or the momentum has reversed. So final momentum will be given by minus 0.4. So change in momentum will be given by 0.8. Okay, so the magnitude of impulse is 0.8. Okay, so option B is correct. Now next problem. This problem is very simple, slightly conceptual. The binding energy per nucleon for the parent nucleus is E1 and that for the daughter nuclei is E2. So you have a nuclei which gets disintegrated and gives your daughter nuclei ND. Now the basic reason behind this kind of disintegration is that this nucleus is not stable. So it goes to a more stable nuclei, which is daughter nuclei. Now the binding energy which is there between the nucleons, it is less here and it is more here. That is why it is going to this stable daughter nuclei condition. So E2, that is binding energy per nucleon in the case of daughter nuclei, will be definitely more than the binding energy per nucleon for the parent nucleus. So option C is correct.